Alright, we'll call this 16b. And let me see what we're going to do here. There we go. We'll start off pretty easy right here. Let's start off with this. Actually, the other day I started going with a little bit of a bigger pen instead of 1 point. Because I was looking at it, I was like, it looks too skinny. It doesn't really show up too well. So now I'm going with 2 points. Does that look a little brighter? Yeah, I think so. So watch this. This is 12 to the 5th over 12 squared. Now remember the rule for multiplication, right? When you have the same bases, for instance, if I had x to the 3rd times x to the, I don't know, 5th, what's the rule for the when you multiply them together? You add them up, right? So this is going to be x to the what? To the 8th, all right? What do you think the rule is here? You subtract. Yeah, we've talked about this. This is nothing brand new. But do you remember what a little method that I kind of showed you? If you have 12 squared, this is 2 12s, right? And then 5 12s on the top, right? 2 12s on the bottom. So watch, 2 of these 12s cancels with what? 2 of these. How many do we have left? 3. I mean, that's basically subtraction, isn't it? But sometimes it's a little easier to see it that way than do subtraction. For instance, what if you had this? What if you had like 5 to the 7th over 5... No, yeah, we can do that. 5 to the 10th. What if we did that? Okay. Now, you could subtract the exponents, couldn't you? But what would it be? If you subtracted the exponents, it would be 5 to the what? To the negative 3rd, right? But then what would you have to do to that 5 to the negative 3rd? Flip it and make it 5 to the 3rd down here and a 1 on top. Do you agree? And that's fine. That's perfectly fine. There's nothing wrong with doing it that way. But here's what I like to do. This means I have 5 7s on top. This means I have, 7 5s on the top. And this means I have 10 5s on the bottom. So what am I going to do? I'm going to cancel out 7 of these with 7 of these. What do I have left? 3 of them. So look, if this canceled out, I still have a 1 on the top. And there you go. It's 1 over 5 to the 3rd. Would you agree? It's the same thing, right? I kind of like doing it this way better, don't you? Okay, we kind of like canceling stuff out. Just to show you the rule, because the rule says we subtract the exponents, and so people like to do that, and that's perfectly fine. There's nothing wrong with subtracting the exponents, but if I subtract them when the bigger one's on the bottom, I'm going to get a negative exponent. But then you still have to take that negative exponent and flip it and change it to a positive exponent. 5/3 would be wrong, that's right, because it's 1 over 5/3, because the 5/3 is in the denominator, not on the top. Okay, so it's a completely different answer, 5/3 compared to 1 over 5/3. Make sense? Okay. What if you had like this? We'll use a letter this time. What if you had that and that? Okay, x to the negative 3rd over x to the positive 2nd. Well, what do we have here? We've got a negative exponent, do you? You could do this. Watch, you could subtract the exponents. So let's do it that way. If we subtracted the exponents, the base stays the same, so it's what? Negative 3 minus 2, which is negative 5, right? But then I change it, what would that be? 1 over x to the 5th. And that's a perfectly fine way to do it. There's nothing wrong with doing it that way. But I'm just going to show you a little technique here that sometimes is a little helpful, all right? Especially when these are going to get a little more complicated. We're starting off real basic right now. They're going to get a little more complicated, but I'm going to show you this little method. This is what I do. I think of this as a negative exponent. What can I do with a negative exponent? We talked about this a bunch yesterday. Flip it to the bottom, and that becomes what? X to the 3rd, right? Now what are you left with? If everything cancels out, what are you always left with? A 1, right? Because 1's being multiplied by all that stuff. So it's a 1 over what? X to the 5th. And you look at this and you say, oh, that was more complicated than doing this. But when you have a whole bunch of them, when you have a whole bunch of letters and variables and exponents and all that kind of stuff, this is going to come in much more handy. What I just did, it's a negative exponent. We talked about this yesterday when we had a negative exponent. You flip it, and then when you flip it, you change the sign of the exponent. So if I take this x to the negative 3rd, flip it to the bottom, it now becomes x to the positive 3rd. So it goes away here, so I canceled it out here. It becomes an x to the positive 3rd on the bottom. Right? So when I took this and I moved it, I'm left with a 1 because everything's being multiplied by 1. Even though you don't always see it, a 1 is always there. So if I take everything and flip it to the bottom, I'm left with a 1 on the top, and now I've got x cubed times x squared, and that's x to the 5th, but it's on the bottom, isn't it? Okay? How did I get this one right here? This is the first way that I did it. I went I went negative 3 minus 2. Because remember, you could subtract the exponents from each other. So negative 3 minus 2 is negative 5. All right, and then I just changed this to a positive exponent by flipping it again. I kind of like this technique right here. Maybe not just for this particular problem, but for what we're going to do here in just a few seconds. Okay? Let's do one that's a little bit more involved. Yeah, here's a good one. If you have your book, this is on page 55. It's example 2D. But you don't need it. R to the 7th, Z to the 5th, over, and that's 10 R to the 9th. 10 R to the 9th. Tell you what, I'm gonna add something to it. So this is not in the example. I'm putting this in there just to jazz it up a little bit, okay? All right, so here we go. Remember, this is a division problem, isn't it? All right, so let's look at the regular numbers. Forget the variables with the exponents. Let's look at the regular numbers. I have a 25 on the top and a 10 on the bottom. 5 goes into both of those, exactly right. So 5 goes into that 5 times, 5 goes into that twice. All right? That was easy, right?
5 go into 10,
Yep.
10 times.
What?
Oh, no.
Yeah. So anyway, there we go for that. Look at the R's. Now look at this right here. Look at the R to the 7th, R to the 9th. You could, if you wanted to, subtract the exponents, couldn't you? You could go 7 minus 9, but then you're going to get an R to the negative 2nd, then you got to flip it, right? What I'm going to do is this. I'm going to say this. 7 of these R's goes into what? 7 here. How many do I have left? 2 of them, so I got an R squared on the bottom. Does that make sense? It's a little easier, don't you think? I think so. Look at this right here. Now I got negative exponents. What am I going to do here? Take that Z to the negative 3rd. I don't want it as a negative exponent. I'm going to do what to it? Flip it to the top. But if I flip it to the top, I have to change something else. What do I have to change? Make it to the positive 3rd. So I took it from the bottom, which was to the negative 3rd, flipped it to the top, which is to the positive 3rd. Jared, you getting all this? So now, what can I do? Let's clean this up a little bit. What do I have on top? Got a regular old 5. What about my letters? Z to the what? To the 8th. Good. And then on the bottom, what's my number? A 2 and then an R squared. And that's it. And it's simplified. So these problems are going to say to simplify. All right? Or simplify each expression. All right? That's not so bad, is it? The Z's, I took the Z to the negative 3rd and I flip it to the top. Okay? I took this and I flipped it to the top. All right? If I flip it to the top, I can change the exponent, right? I mean, I have to. That's the rule. If I flip it either to the top or the bottom, if it's a negative exponent, or if it's any exponent, really, positive or negative, I flip it and I change the sign of the exponent. So it was negative, so I flipped it to the top and changed it to positive. Now, you could have done this. This might have been just as easy. But sometimes, the reason I teach this way is because sometimes kids get confused. Because I could have just subtracted the exponents, couldn't I? I could have said what? 5 minus what? Negative 3. What's 5 minus negative 3? Positive 8, so Z to the 8th. So I could have done that. And that would have been fine. There wouldn't be anything wrong with that. But what I've noticed is a lot of students would do this. A lot of students would say, oh, 5 minus 3 is 2. I've seen that so many times. You wouldn't believe how many times I've seen that. But you could kind of see why, couldn't you? But it's not 5 minus 3. It's 5 minus what? Negative 3. So to try to combat that, I like to take all the the negative exponents, flip it so that they're positive exponents. That way, it's just a little easier to work with, I think. I think most students feel it's a little bit easier to work with the positive exponents than it is with the negative exponents. Do you think you'd agree with that or not? Okay. It's up to you on how you want to do it, but I'm showing you both ways. All right, let's do, all right, let's do this. This is a little bit different. So 3x to the negative 2nd times, this is going to be a distributive, but we're going to have negative exponents all over the place. But your rules still apply. Even though your exponent is a negative, your rules still apply. All right, there it is. It says to simplify. what do you think you want to do? Are you going to distribute, though? So what's the rule? My dear Aunt Sally, right? Please excuse my dear Aunt Sally, remember that? So we do parentheses first. Well, we can't really simplify too much in here, but then you do what? Exponents. So we're going to have to do this stuff first. So do you see this stuff right here? We're going to have to figure out what that is before we multiply it by this 3x to the negative second. So let's see what it is. So let's keep this the same, all right? And let's figure out what this stuff is. Now look, the base is 4, right? So what do we do when we have an exponent taken to another power? What's the rule? Do we add them? We multiply them. When you have an exponent to another exponent, we multiply the exponent. So this is going to be what? 4 to the negative 2, right? No, we're already, it'd be like this. It'd be like x third to the 7th, right? What will you do? You keep the base the same, right? And you just multiply the exponents. Right here, our base is 4, so we keep the base the same, and the only thing we do is we multiply the exponents together. Does that make sense? All right, sometimes we get a little confused when the base is a number, but it works the same way as if it was an x. All right, let's do this one. This one's a little easier to see. It's x to the what? Negative 10th. Good. All right, so we did the exponent first, didn't we? Now we can go ahead and multiply. So let's see. Do I just go 3 times 4, though? Nah, you got to be careful, because this is what? 4 to the negative second, isn't it?
Wouldn't that be 2?
Yeah, I'm trying to think of the best way to do this. Let's do this. Let's go 3. Let's multiply the actual numbers together, right? This is 3, and this is 4 to the negative second. So instead of 4 to the negative second, how can I write that? 1 over what? Now it's not 1/4 to the second. That would actually be the same thing, but I'm going to write it like this. What do? I flip this to the bottom, right? So that's 1 over 4 squared.
Wait, I'm not sorry. I was thinking.
That's all right. Okay, see what I did? I'm just taking those two numbers and multiplying them together, just to kind of put them together. Now we can take the x's and multiply them together. So I get x to the negative second, x to the negative 10th. What's that going to be? X to the, what's the rule when I multiply bases together? What do I do with the exponents? I add the exponents, right? So what's that going to give you? No, add. I add. Don't multiply. You're adding the exponents together. This is a multiplication problem, but the rule for multiplication says keep the base the same and add the exponents. So it's going to be x to the negative 12. Yes? Because this is just a number, and this is just a number, I take the regular numbers and I multiply them together. For instance, if I had 3x times 5y, what do? I take the 3 and the 5, multiply them together, don't I? Okay, and then I take the x and the y, multiply them together. It's the same process. So what's this going to be? This is going to be 3 over 16. Okay, and what do we do here? Take this, chuck it to the bottom, so it's x to the 12th, and that's your answer right there. Okay, let me give you a worksheet. I'm glad he left without getting a worksheet. And then you can try to work on these this weekend.